All right, let's get right into it. We're about to look at something that's kind of hidden inside our most complex systems. It's a vulnerability that can bring down everything from power grids to stock markets and, yeah, even entire ecosystems. This is the anatomy of a collapse.
So, let's kick things off with a bit of a riddle. You've got a massive blackout, a financial panic that happens in the blink of an eye, and the quiet disappearance of a plant. I mean, what in the world could possibly connect these three things? They seem like they're from totally different universes, right?
Well, the answer is actually pretty simple, and honestly, a little scary. Every single one of them was a chain reaction set off by one tiny, seemingly insignificant failure that just spiraled completely out of control.
And there's a name for this: cascading failure. The definition here really nails it. It's when one part of a system breaks, but it doesn't just stop there. Nope. It takes the next part down with it, and then the next, and the next, getting bigger and bigger as it goes.
The best way to picture it is a world made of dominoes. Once you tip that first one over, you know the rest are going to fall. So let's take a look at how this chain reaction plays out in the complex systems that are all around us. Let's start with something we all rely on: power grids. So when a single transformer fails, the electricity it was carrying doesn't just disappear. It has to go somewhere, right? So it instantly tries to find another path, rerouting to neighboring lines. But here's the problem. If those lines are already close to full capacity, that extra jolt of power pushes them over the edge. So they fail, shoving their combined load onto the next set of lines. It's literally a ripple effect of overload spreading across the entire grid. And listen, this is not just a theory. Take a look at this timeline, from North America to India, from Italy to South America. These massive, widespread blackouts that affected hundreds of millions of people, they were all classic cascading failures. A small local issue blew up into a massive international crisis in just minutes.
You see the same exact logic on the internet. If a key data router goes down, all that traffic, all those emails and videos, gets immediately shunted to other routes. But those routes get clogged, they slow to a crawl, and then they start to fail too. It creates an even bigger digital traffic jam. It's why one little bug in some code can sometimes feel like it's taking down the entire internet.
Now, in the physical world, think bridges and buildings, engineers have this really fantastic name for it: the zipper effect. And it's the perfect way to think about it. Imagine just one tooth on a zipper breaking. All of a sudden, all that pulling force gets concentrated on the two teeth right next to it. They can't handle the strain, so they pop, passing that insane load down the line until the whole thing just rips wide open. And this is a tragic real-world example. At the Hyatt Regency Hotel back in 1981, a walkway collapsed. And when investigators looked into it, they found a design flaw had put double the intended load on a single suspension rod. When that one rod gave way, it instantly shifted an impossible amount of weight to the rods next to it, and they failed, one after another, just like a zipper.
But this isn't just a story about our engineered systems. This exact same pattern of collapse exists in maybe the most complex system of all, the natural world. In biology, they call it co-extinction, and it's based on a simple, kind of brutal fact that in the web of life, no species is an island. When one species disappears, any other species that relied on it, for food, for pollination, you name it, is suddenly in very serious trouble.
You know, this quote from Dr. Giovanni Strona really gets to the heart of it. It doesn't matter how tough a species is, how adaptable it might be. If its primary food source is gone, it will eventually disappear too. The cascade is basically inevitable.
And this brings us to what's called a keystone species. So picture a very specific type of bee that happens to be the only pollinator for a particular flower. If that bee species dies out, well, the flower can't reproduce anymore. It's now on a one-way trip to its own extinction. The first domino has just fallen.
So we've seen how these dominoes fall in our grids, our buildings, and our ecosystems, which leads to the really big question, right? How do we stop it? How do you actually design systems that are built to withstand failure?
So if these failures are lurking everywhere, what can we do? Let's look at how engineers and scientists are actively trying to, break the chain.
To really get this, we're going to look at industrial safety and a very specific and scary type of accident called a bleave. It's what happens when a tank full of pressurized liquid gets heated up by a fire next to it. The pressure just builds and builds until the whole tank ruptures in a massive fireball. This is a classic domino tipper. Now, check out these diagrams. They actually map out the threat zones for these kinds of accidents. That red circle in the middle, that's where the heat is so intense it could cause a neighboring tank to fail.
So the #1 job for a safety engineer is to make absolutely sure no other critical tank is inside that zone. That's how you stop one fire from starting another. And this really shows you a core strategy for building resilient systems, creating buffers. Here, it's a literal, physical safety distance, but the principle is universal. In network design, that buffer is redundancy, having backup servers ready to go. In the stock market, it's a circuit breaker that literally stops trading. The goal is always the same. Create a gap so the chain reaction has nowhere to go.
And this table shows how it's done in the real world. Engineers don't just guess, they calculate everything. They model not just the first failure, but how it spreads, what they call the escalation vector. For a bleave, they don't just plan for the heat, they calculate how far flying fragments could travel, up to 500 meters. Every single risk has a specific, calculated buffer designed to keep it contained.
And this whole process is incredibly rigorous. They analyze past accidents, they model absolute worst-case scenarios, and they define the exact thresholds that could trigger a cascade. It's all about building systems that don't just work, but are designed to fail gracefully, to fail in isolation without taking the whole system down with them.
Okay, so let's zoom all the way out for one final thought. We've talked about how individual systems can fail, but what happens when the systems themselves are the dominoes?
The thing about our modern world is that our most important systems are all deeply tangled up with each other. The power grid needs the communication network to work. The transportation network needs fuel, which needs power. And the financial system needs all of them. They're totally interdependent. The 2003 blackout in Italy is just the perfect and frankly chilling example of this. When the power grid went down, it wasn't just the lights that went out. The entire railway network shut down. Healthcare systems were hit hard. And here's the kicker. It also took down the communication systems that the grid operators needed to fix the original problem. It was a vicious feedback loop. Which leaves us with this one last question to think about. In a world where absolutely everything is connected, maybe the greatest risk isn't some huge, obvious disaster. Maybe, just maybe, it's the smallest, most overlooked component, that one tiny domino that nobody's even watching.